In mathematics, what is continuity? What does it mean? Now see this road. This is a path at straight. You can easily drive through. Here you have a winding road. That means the road is there. It is winding, but still you can drive properly if you are a good driver. So these two roads are continuous. Now imagine that you are stuck in this kind of situation where the road is actually going down or breaking. Then it is not continuous. Here also you have a hole in between a road. There will be a problem. So this means discontinuity. The above two, continuity, below two, discontinuity. That means you have a path, if it is straight without breakage, or you have a path with certain breakage. So the first one is continuous, second one is discontinuous. Now this is the conceptual meaning of continuity. We have, say, in mathematics functions. For example, y equals x. So function is y equals fx basically. Now this will be a straight line. Any function will have any graphical representation. Now this graphical representation, if this line or a curve is straight or without any break, then we call it as a continuous function. But if you have a break, there are different kind of break, there are different kind of discontinuity, then we'll call that this function or this curve is discontinuous. So this is the concept. Coming to the mathematical aspect of continuity. Now we have a function fx. You know function? You have to have the idea of function to understand continuity, differentiability, etc. and limit, of course. So the continuity, the precursor is limit. So limit, if limit exists, what does it mean? That if you want to find out that whether this point, at this particular point, the road is proper or not, that is, you want to find out this for this function at this particular value or that this particular point, whether it is continuous or not. Let us take any point. For example, on x-axis, we take x equals a or x equals c. So we need to find out whether this curve which you see in yellow at point C or at point A, whether it is continuous or not. So mathematically, how are we going to find out? We will find out the limit. The left hand limit and the right hand limit, if they both are equal, then the limit exists. Okay. Now the value of this function fx at C or at A, when this becomes equal to the left hand limit and right hand limit, that is the actual limit, then we say this function is continuous. I hope you got the idea. I'll show you here. So this is a graph. I'm not showing the right part, only the left part. So if you want to find out the continuity at x equals a, you will just move back a little bit, very minuscule or minute. Then you will just go ahead farther from x equals a. At these both points, if the limit exists, and then we'll try to find out when x equals a, what is the value of the function, that is fa we need to find out. If this fa is equal to the left hand limit, is equal to the right hand limit, if this exists, then we call it as the function is continuous. So let me just give you the actual function fx when it is called continuous at certain points, say x equals a or x equals c. When the function is well defined at this point and the limit, left hand limit, right hand limit, the value which limit will give you is actually equal to when you put this a in the function fx. So without any break, if you get a curve or a function, then we call that this function is continuous without any break. Means checking for limit and checking for the actual value of the function at that point is basically done in order to find out whether there is any breakage or not. Okay, so fa is the value of the function at a, and this is equal to the limit of the function at this particular point a. So if you're aware of limit, you know how to find out the limit, and for getting the value of the function, just put a in the function. So fx is continuous at x equals a. That simply means that the graph or the curve of y equals fx has no breaks. Whenever we go for calculus, differentiability or limit, etc., we will have certain intervals. Now what does it mean? We generally, will encounter the square brackets and the round brackets, because the domain can be, or the range can be, or the boundary can be different. So there can be multiple intervals. For example, you have this line, you have point A, point B. So this comes from the Cartesian coordinate system. Now it starts from negative infinity to positive infinity in x-axis. Similarly, in y-axis also, it starts from positive infinity to negative infinity. Infinity is not defined. We don't know that number. But if you want to check the continuity, see, you don't want to find out the continuity for the whole curve. Maybe you want to find out the continuity at certain interval. So when you have this a and b included, that is less than equal to or less than equal to sign is already there, then we'll use the square bracket. Okay, then this a and b is included. When a and b are not included, then we'll use the round bracket. So whichever is not included will be, that will be followed only after the round bracket. And whichever is included, whichever number or the value is included, that will come only after the square bracket. So, for example, you just need to find out between A and B, whether it is inclusive, whether it is not inclusive, then you will show it using the square bracket. So there can be multiple intervals, multiple ranges. For example, minus infinity to A to B, B to A, infinity to minus infinity, B to minus infinity, A to infinity, B to infinity. There are so many combinations. So what are the different kinds of continuity in mathematics whenever we are talking about calculus? Again, I am telling you, a function may have some break, but it may be continuous at certain interval. For example, if you want to go from A to point B and that road is perfectly all right, just after B it has a breakage, but you don't have to worry about this because you just have to reach B. So when you are being asked, tell the continuity between A and B, you will tell, oh yes, it is continuous. Okay, so wherever you see this figure, I'll just take one by one. This function is continuous when A and B are included. So A point, B point, this is actually on the x coordinate. Here, A and B are not included. Still the function is continuous because there is no breakage, you see. A and B are not included here. If you include A and B, it will not be continuous. I hope you got the idea. Here, you see, we cannot include A. So it will be a round bracket, and infinity, of course, we don't know about infinity. It will always be in the round bracket. So fx is continuous on this interval, not including a, but after a till infinity. And this from negative infinity to positive infinity, this function is continuous, no problem with that. And here there is a sudden dip, there is a sudden break, but still if you include a, go on the left hand side, you see from a to negative infinity, as I said, a will be included, infinity is not included, this is continuous. So for certain interval, the continuity can be there. So you may be asked, what are the functions? For example, polynomial functions, exponential functions, these are the polynomial functions I am writing. So ax cubed plus bx squared plus cx plus d, like this. And the exponential functions and the sine, cos, all these graphs, these are certain examples of continuous function over the set of all real numbers. So these are different kinds of continuity, but you need to understand the interval where it will be continuous, where it won't be. So there will be certain kind of discontinuity also. So what are the kinds of discontinuity? Let me give you first a function fx. Whenever we say it is discontinuous at certain point a, please remember we need to tell at what point you have to find out the continuity or discontinuity. So at x equals a, if it is discontinuous, that means it is not continuous at x equals a. That is, the limit of x tends to a is not equal to the value of a at that function. So this is a kind of jump discontinuity, or we can call it as a non-removable discontinuity. At x equals to a, whatever you do, you will not be able to get this function continuous because the limit extends to a of this function fx, whichever function this is basically a breakage function. You see, this doesn't exist. Step function it is. Second, I am showing you it is a removable discontinuity. You can see that this function has no breakage. But it totally depends where you need to find out the discontinuity or continuity. So limit extends to a fx exists, but it will not be equal to the value of a at that function fx. Now infinite discontinuity, the left hand limit and the right hand limit, they are infinity or minus infinity. So these are different kind of discontinuity. This one way, another way, third way. Now the third one, you will say, oh, it is continuous. Why it is not? But there can be certain peak or crest or trough that may a certain change in the, say, you have seen the mountain, like that kind of peak. If it is, sometimes the left hand right hand limit doesn't match, and that may create a discontinuity. So that point is very important where you are checking the discontinuity. And let me tell you, differentiability, it's all about dy by dx, the slope at this point. Let us take the example to test the continuity of any function fx. So we are going to check a function fx which is given here, and y equals fx is the function. And whenever we put the value of x, we'll get the value of y, and y is nothing but fx. So you can always write x comma y or x comma fx. So this point is very important where you need to find out the continuity or discontinuity, and this point is given as x equals 0. The question is giving x equals a. Remember I told you x equals a is nothing but x equals 0. A is 0 here. So if x is not equal to 0, it is given x by modulus of x. If x equals 0, it is given as 1. Now let me tell you what will be the criteria. I have taken this question somewhat typical because basic questions you won't be understand the properties, different properties. So we'll try to find out the left hand limit first. The left hand limit, whether it is equal to right hand limit, first we have to find out that. X equals a, remember here a is 0. So x equals 0 here. Now left hand limit, this is a, we just go a very infinitely small value behind it. That h is very small, very h tends to 0 actually. And right hand limit, you go just a bit ahead, h, which is very small, very infinite small value. So x equals 0 minus h will take always in left hand limit, x equals 0 plus h will take always in the right hand limit. Now this function is already given to us as we were discussing about function. F0 minus h is f0 minus h is minus h only. F minus h, since fx is already given, x by modulus of x. In place of x, just replace it by negative h. So negative h, so limit h tends to 0. H is a very small number. It's actually equal to 0. So minus h divided by the modulus of negative h. So this modulus of negative h is h only. So minus h by h it will be. Limit h tends to 0. H gets cancelled. You get negative 1. And now you don't have to apply the limit because there is a constant number, minus 1. Okay. Coming to the right hand limit. Now x is 0 plus h. So again, we'll put this 0 plus h. Actually, it is equal to h in fh or fx. So limit h tends to 0. In place of x, I'm replacing it by 0 plus h, or you can call it as h. H by modulus of h. Modulus of h is simply h. So limit h tends to 0. H gets cancelled. You get 1. Now you see, the left hand limit is not equal to right hand limit. So when the LHL and RHL are not equal, you don't have to go for finding out the value of the function at a, that is at 0. Why? Because the left hand limit and right hand limit are not equal. That means this function is discontinuous. It is clearly showing it. And then you will go to differentiability, because the function is not continuous, there will be no differentiability, right? So let us take the value at 0 also, x equal to a. It is 1. So 1, in case I'm just giving you an idea, if this left hand limit and right hand limit are equal, and say that they are 1, and if it is equal to f0, that is 1, then you can say that it is continuous. But in this case, they are not continuous because the limit left hand and right hand are not equal. Okay. So this is all about this discussion. Thank you so much. Take care of yourself.